Aloha all. From reading your technical essays and also seeing the way you guys have been doing on the first underscore WAD, it's clear to me that this is conceptually kind of a hurdle for you guys. So I thought it might be useful to create a tiny little screencast with some really basic examples of using the underscore library that you can use to maybe improve your own understanding, and at the very least, when you're trying to understand how a new function in the underscore library works, you could use code like this as a basis to just play around with the functions and see what they do. So the first thing that I want to go over is the idea that in JavaScript you can pass functions as arguments. I kind of forgot what a mind-blowing idea that would be for a lot of you. To me, I'm kind of used to it, so it's not such a big deal. But really, it's an incredibly great thing. Okay, so let me start by saying here's a little function. It gets passed a value num, and it's going to add to it. Okay, and if I uncomment this line, and I'm putting a bunch of spaces in this console log so that it's really clear that the middle part is what I want you to focus on, and don't worry about that console log thing because it's just kind of extraneous garbage. But if we were to do run, okay, what we can see here is that if I call this function add and pass it an argument 2, it returns 4, and that is nothing abnormal, right? Everybody, you've taken a couple semesters of programming, you've wrote a billion functions like this. It's no big deal. You take kind of atomic value and you invoke an operation on it. Nothing unnatural about that. Okay. Here's a function that's a lot more tricky because what we're saying is we're going to take an argument, and we're actually going to, and that argument has to be a function that takes one one single parameter and does something with it. Okay, so we're going to take this adder function and we're going to do something with it. In this case, what we're going to do with it is we're going to pass in another argument that this function is passed. Okay, does that make sense? So we've got a function, we've got some other object, we're going to invoke the function and pass that object into it. So if I comment this out and uncomment this line, what we're going to do is we'll invoke this function, run the adder, and we're going to pass into it our add2 function as well as a number 5. So this function here is going to invoke add2 and pass it the number 5. Okay, so let's invoke run, and we see we get a 7, which is what we expect when we add 2 to 5. Okay, so this is the key thing. I know it's a little hard at first to wrap your mind around, but basically the cool thing is functions are just objects like any other thing. They're really no different from integers or strings or arrays. They're just functions. And you just pass them around, and even later on you'll start returning them as values because that's totally good as well. So this is just kind of a new computational degree of freedom, I guess you might think of it, and it's very, very useful. All right, and in fact you've got to be able to understand this because basically every single underscore library function wants you to pass it in a function to do something. Okay, so now let's look at a few of these underscore functions to get you started. I'm going to start with the each function, and so the each function basically takes a list and then some kind of function, and it's going to invoke function on each element of the list, and basically that's all it's going to do. It's going to actually return the original list as the return value, so it's called for its side effect. Okay, so that's why in the underscore example they have you, they show you the alert function. Okay, so if we uncomment this and then we run, what we can see is we have this array of values 1, 2, 3, 4, 5, and we called each, and with that array of values 1, 2, 3, 4, 5 and our add2 function. So inside, we were adding 2 to these numbers, but who cares? Because what this each function actually returns is the original list. Okay, so that's what I mean by calling it for its side effect. There's something that happens inside, but basically the return value is not going to reflect that. Okay, so that makes each kind of, in my humble opinion, a less interesting function, although sometimes you'll find it to be worthwhile. Okay, let's look at map. Map is one of the most fundamental of the functional kinds of functions. And what map does is map invokes function on each element of the corresponding list and then returns a new list, which is the result returned by function on each of those elements. Okay, so let's call our map function. We're going to pass it our array of numbers, 1, 2, 3, 4, 5. And so I say list here, okay, and a list, in JavaScript, is an array, okay, for the most part. So we have this array or list of numbers, and we're going to invoke our add2 function on each of those numbers, and we're going to return a list that's a result of doing that. So just sit here in your brain and say, what the heck is this going to return? Before I hit the run key, what is it going to return? Here's my array of numbers here. Okay, got it? Everybody know? Let's try. There it is. Okay, so it added 2 to each element of the list and then returned that new list, which has exactly the same number of elements, but those numbers have been transmogrified according to the function that we passed in. Okay? That makes map a super useful function, because from all our, the WADs and so forth, that normally what we want to do is we want to kind of compose together these functions by taking the result from one function and passing it into the next function. Okay, so that's good. That's what map does. Okay, let's go on to reduce, which is another really important function. Reduce is going to take a list of values and reduce it to a single value. Okay, and there's all sorts of, if you pass in strings, you could reduce a very big string to one single string. If you pass in numbers, you could take a large number of numbers and reduce them down to a single number. If you take a whole bunch of arrays, you could reduce them down to a single array. It's all that kind of thing. Take a lot of objects and then reduce it down to a single object. I say, kind of addition of results, but that's metaphorical, right? I mean, you could really be doing anything with it. Okay. The way you do this, you have to have what's called a memo function, okay, and an initial value. The memo function has to take kind of the intermediate results of having done the reduction. It gets passed in, and then the current element that we're going to worry about, and then the goal of your body is to say, okay, well, given the reduction so far, we've reduced a bunch of it, but we've got more to reduce still, and here's the next element in our original list, okay, you got to figure out, as the client, you've got to figure out, well, what does it mean to reduce it with yet one more element, okay? And so the classic example is a memo function that's just going to add up all the elements in the list, and the way that works is to say, we just take whatever we've, the intermediate result so far, which is the sum of elements so far, and we just add the new element to it. Okay, so if I comment out this, and then I run that, okay, what we see is that hopefully 5 plus 4 is 9, 9 plus 3 is 12, 12 plus 2 is 14, and 1 is 15. So that's the result of adding up all those numbers, and so you can see we called reduce. Here's our list of numbers 1 through 5. Here's our memo function right here. And then we have to say, well, what number do we start with? So, just for grins, I mean, we could start with 5 and run this again. And then, of course, it's going to add up to be 20. Or we could start with, I don't know, minus 5 and run it again. And then it only adds up to 10. Okay, so that's our kind of our initial condition. And it might be good for you, think about an array of strings that you want to reduce into a single string. What would that require you to do? But, I mean, reduction will work just fine on that as well. You just got to think about how you'd want to manipulate. Maybe you want to concatenate a whole bunch of little strings into one humongous string. Okay, so that is an example of doing a reduction on non-numeric values. Okay, so that's our reduce function. Find function, okay, is the next one. The idea here is we've got a list of objects, we've got a predicate. A predicate is a special function. We call a function a predicate function when it takes an object and returns true or false. That's essentially, whenever you hear me talk about predicate, that's what I'm talking about. Okay, and so we're going to invoke predicate on each element of the list, and we're going to return the first element in our list for which the predicate returns true. So here we have a predicate called is a lot. There's a lot of it, okay, and we're going to pass in a num, and we're going to say a number is a lot whenever that number is greater than 2. Okay, so let's try this. Okay, so we're going to call our find function, pass it a list of elements 1 through 5, and we're going to pass in a function, our predicate function that says the number is a lot when it's greater than 2. Okay, so what do you think this console.log statement is going to return? Everybody got it? Okay, let's try. Let's try. There we go. Oops, I don't know why it... Okay, so it returns 3, right? Which is the first number in our list of 1, 2, 3, 4, 5, which is greater than 2. Okay, so that's pretty easy. Let's go on to filter. Okay, filter is kind of a very similar function, except what it's going to do is it's going to invoke predicate on elements of the list, but return all of the elements that pass. So if we call filter with our list of 1 through 5 and with our is_a_lot function, what do you think that's going to return? 1, 2, 3, 4, 5. Okay, that's our original list. We invoke run, and we get 3, 4, and 5. So all of the elements in this case are going to be returned. Okay, so that's that one. Let's go on. Our last example here is group by. And group by is a little more complicated, and we've used it in some of the WODs, and that's been, I think a little more complicated for you to understand. But in fact, it's not that big a deal. It just says that we're going to take a list of things, we're going to apply the function to it, and depending upon the return value of the function, we're going to create groupings. Okay, so and the groupings are going to be an object where we get the return value of the function, and then all of the elements of the list, which when the function is applied to it, return that value. Okay, so this one wasn't spaced out like the other ones. Okay, so there's our example. We're going to group by. We're going to have our numbers 1, 2, 3, 4, 5. We have our is_a_lot function, which returns true if it's greater than 2 and false if it's not. Okay, so let's try running that and see what the heck we get. Okay, well, this is pretty interesting. We got ourselves an object where the keys are the 2 values that can be returned by is_a_lot. Is_a_lot can return true or false. Okay, and then the value corresponding to false is an array of two elements, and those 2 elements are the elements in our original list 1, 2, 3, 4, 5, for which is_a_lot returns false, which is 1 and 2. And then the second element of this object is a key value pair, the true being the return value of our predicate, and all of the elements of our original list for which our function is_a_lot returns true, which is 3, 4, 5. Okay, so that's how that particular function works. All right, I'm going to stop here. And I hope this has been useful to you, and you can play around. You can go to this URL and play around with this yourself. And what I recommend you do is, just construct little example functions. I know that, they have these examples here, and some people were complaining, I couldn't really understand it. Well, shoots. Just create a little fiddle and start playing around with it yourself. And oftentimes, I think with a little bit of playing, you'll figure out exactly how this works.